On the far left square. Okay, on the far left square. Actually, since you did only 9. Or, yeah, do it. Do it on the far left of it. On the far left of it. So it's going to be, yeah, right here. Exponential laws. Exponential laws. Yeah? These are mathematical laws, not judicial laws.
No, they're not.
No, because if you get questions wrong in tonight's homework, it doesn't mean you can be charged by Officer Davis. Exponential laws. Exponent. IAL laws. Exponential laws. No, we're going to be doing notes if we can, hopefully we can see it. Law 1, multiplication. And if you can't see that, feel free to move closer. I can even move the stuff off of this chair. It's going to be teeny tiny writing today.
It's just so cute. It's so small.
Oh, it's Monday.
Yes.
Right there, right?
Oh, yeah. This is going to be the top left box. If you have 3 along the top left box. And do you need something else to write on that? So exponential law, multiplication. When multiplying like bases, you add the exponents. Yes, as it is in the middle top on your screen, yes. When multiplying like bases, you add the exponents. When multiplying like bases, you add the exponents. Yeah. Because then it holds true with exponential form. We'll show you. There'll be an example. It's when you have a number with a number, or a number or a variable with another number or variable on its shoulder, like x squared.
Like a pi. Oh, like exponents?
Yep.
Oh, I get it.
Did you just throw your voice? Did you just throw your voice? I'm kidding. Never mind. For example, holy cow, that's small. So, examples. A squared multiplied by, and please be sure to use that dot for the multiply. A squared multiplied by 4 equals A and 2 plus 4. A to the power 2 plus 4, which means A equals 6. Also, 2 to the third multiplied by 2 is equal to 2 to the third plus 1, which equals 2 to the fourth. But is equal to 16, because 2 times 2 times 2 times 2 is 16. Yes, sir. That's why I said if you need to move closer, feel free. There's plenty of room, so we can be like it's reading time in elementary school. Right? Does it apply to this? No, then no. Then there's also, in parentheses, that is the quantity of negative 3 squared y to the fourth times the quantity negative 2x to the fifth y to the seventh. And I can work that one out.
Do we have to write that? Can you write it bigger for a second?
Not right now. Actually, I can try it. Let's see if I can do this. Because if it's just an image, I can... Here, I'll freeze your guys' screen. Try to get that bigger. Copy. No. All right, it's going to be very grainy. Like that.
Ooh, that kind of hurt.
So I'll explain. I'm recording it right now. I'm recording it right now, and also I'll save these images and put it straight on my website. Yes, when there's no sign between variables, that is multiplication.
For fun. Just for it.
Ah, sorry. Sorry.
There we go.
I just see people trying to look. Oh, by the way, we are going back to our old seating arrangement because of all the stuff, all of this that happens, where people can't see.
Got it.
It's the I can't see dance.
That's a bad dance. What is happening?
I'm pulling something. That's what's happening.
Oh, I pulled my back one. I pulled my voice.
I wish I could roll my voice like to say hi.
All right, hey, you might be done, and you're like, hey, it's time to talk. But there's still people copying down, so please be respectful for those who are trying to focus and making sure they take this stuff down properly.
What's Y2? I can't see it.
What's Y2?
What's that?
That's the 11th. That's y to the 11th because it's y to the 11th because we have y to the 4th plus y to the 7th. 4 plus 7. Ooh.
You need to drew a card.
4 plus 7 is equal to 11. So that goes here. Yeah.
I have a question on the top one. If we're multiplying 2 to the third times 2 equals 2, 3 to the third plus 1, why would we add 1 when we multiply?
Because that's you.
If you think about it, 2 to the first,
It's the same exact thing.
it's the same exact thing. Because if you multiply 2 one time, that's just 2. So whenever you have x, that's just x to the 1. So we have, no, there's no, oh, this here, that looks like it should be a 1. 1, it is a 2. You're right. Steven's messed me up again.
Yeah, come on, Steve.
All right, we ready with that next one? Okay.
Multiplication. Multiplying things.
Next one we have is division. And I'm going to make this one bigger too. When dividing like bases, you subtract the exponents.
Just like its cousin subtracting. Its cousin? Yeah. They're not. They don't want
If I can do this.
What's a like base?
Like base are the same variable or the same number.
Yes, it is. I don't believe Senior begging. That my same logic makes it so these should be more.
There we go.
Confusing logic.
My logic is so powerful that it makes these shoes bold.
Here's the example of those. So this goes right underneath where we just had all the examples for the multiplication. Because we have y to the 6th over y squared, which is the same thing as doing y is 6 minus 2, which is down to 4.
See what you're saying about this whole I can't see dance thing.
Yeah, now you're all.
I'm trying to do this.
I'm such an idiot. Okay.
Just like me.
Exactly like you. My hair's a little bit more curly, and that's the only difference. So on the 12 x to the 5th, y to the 2nd, and I'm going to explain how this is possible. How is this possible? Let's do this.
Hey, I only went to the brain doctor.
Yep. Exactly. When you multiply. Yep. Well, yes. But I'm going to show you exactly how division works.
I don't think division works at all.
I will show you how division works.
You will?
Who's still writing? Raise your hand if you're still writing. Okay.
I am.
So be quiet and write. Hey, as I just said, even though you're done, other people are still not done, and let them focus. Yes? X is a multiplication sign? Where? That X? No, this is algebra. You won't see X as multiplication.
You just did the A one.
Okay, so I'm going to show you how that works. So we have, where was it? We have 12x to the 5th. Ew, hypocrite. There. 12x to the 5th, y squared, 10x to the 3rd, y. Do you agree? Let me get over here. Do you agree that this is the same thing written out? 1, 2, 3, 4, 5, and y, y?
Yeah.
Okay, and this, x, 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 y. Okay, and do you agree that x over x is equal to 1? Remember we talked about that? Anything over itself is just equal to 1. So what's happening in this situation is, yep, they're canceling each other out, in fact. So this is canceling that, this is canceling that, this is canceling that. So is it safe to say that it's the top minus 3? Or the top exponent minus the other? And we still have the y to get rid of. And then when I simplify this part, it's just 6 over 5. What's left over? X.
You divide each by 2.
Simplifying, you divide it by 2.
Oh, you divide.
So you just divide.
You're simplifying. You reduce. You're reducing. So now I have 2 x's that are left and 1 y that's on top, and that's how that one works that you just wrote down. Yes?
So for the regular one, you just reduce to
Yeah, you just reduce to simplest form. And since it's being multiplied together, you can't make that 1 and... Yeah, you can't make that easier. Because obviously if it was just this, you would have 1 and 1/5. But you can't do that because there's variables involved. Yes?
So 12 over 10, you just cross out all the things, do that, and then get 6 over 5, and then do that like this.
Yeah, you can do the numbers first. Yes?
What if it's like 12 and 12?
12 and 12, then it would be, if this was a 12, then it would just be this. Because this gets itself away, and what's left on the bottom? Just 1. So it cancels itself out, and it's just x squared y. Okay? Sorry. So that was law 2.
There are laws, so if we don't do it, we'll get arrested.
No, we already went over that.
Oh, right, because they're different laws.
These are not judicial laws. This one is law 3 with negative exponents. Law 3 with negative exponents. Looks like. Are you done? It's nice.
Oh, you were in band.
You're a little late.
Okay, we're at law 3. When there is a negative exponent, you flip. When there's a negative exponent, you flip the base and the exponent over the function bar. It's where the exponents hang out on Friday nights. Thank you. I'm glad a couple of you got that.
I got it, but it's
It's like, where do astronauts hang out? The space bar.
Oh, I got that wrong.
it's not good though.
It's like a keyboard. Aiden, what kind that
Okay. I actually have a good one.
But we're not. Let's go. You still didn't even make your boxes that big.
Yeah, but I'm fitting it all in mostly.
When there is a negative exponent, you flip the base and exponent over the fraction bar. The exponent is now positive. Every number can be written as a fraction. For example, 6x is actually 6x over 1. That's not an insult. I'm helping. Is that how I deliver that? Like, oh, guess what? You're wrong because of this. What's up now?
Wait, negative.
0 is 0 over 1. But 0 is not 1 over 0 because you can't split anything into nothing, no groups.
You cannot divide by 5. Oh wait, that's 0.
All right. Who's not done writing that? No, I'm not waiting for you. You're making too much noise anyway. Is anybody else other than that person? Done? Okay.
I'm saying that, yes.
Yes, sir. Everything is the first power of 1. Everything the first power of 1 is the same thing. So 15 to the first 15 one time is 15. Yes. That's a whole different proof thing. Because that would be 2 15s, so 2 exponents. 15. Examples. X to the negative 6th is 1 over x to the 6th. Y to the negative 3 is equal to y to the 3rd. We'll do an Where'd you buy those fractions? At the fraction store?
No, I bought it from the supermarket.
Burke, did you already write down all those examples? Wow.
Which crafts?
Well, finish writing. Are you done writing?
No.
Then don't speak.
Something. Wait, does exponent stay negative?
I will explain when you're done writing. I will show you what's happening. I will.
I trust you on this one.
I'm sorry. You better be sorry.
as I said, I'm going to explain what's happening. I'm not just going to shove it in your face and then be like, okay, next. No, we will talk about this. We will discuss this. This is not easy, so I want to make sure to discuss it. Alicia, question? Nope. Stacy, you got it? Okay. So here's what's happening with this one.
Wait, how did we get B on the bottom and then
That's,
it magically turned from A?
I promise you, I shall show you. We have 3a to the negative 2 times c to the 4th. We have 6b to the negative 3. And then we're going to move along. Now, the law states that any number or any variable or item with a negative exponent is automatically going to be flipped. So that means that this is going to be flipped to the other side, and this is going to be flipped to the other side, and also that our exponent is now going to be in the positive. So this is still 3. This is still 6. Now my b gets brought up here, b to the 3rd, and my a gets brought down here, a squared. C4, which isn't negative, still chilling. Now we still have to simplify what we do know to simplify. That's why 3 became 1 and 6 became 2. So now we have b cubed, c to the 4th, and a squared. Now, do you need to have that 1 in there?
No.
Do you introduce yourself as like, hi, I'm one Mr. Smith? No, it's assumed that you're only one person unless you're Agent Smith from the Matrix trilogy. So that's why it's c to the 4th. Question?
Wait, but how did you get 1 and 2 from 3 and 6?
Are you serious? No, my brain.
Oops.
Oh my
What
god.
else?
Because-
By 3.
No,
Let's read about
Mr.
it.
Smith, you can explain how.
Yep.
One and two.
Do you agree with that?
I do.
That's why.
Okay, good.
Oh, okay. So you just figure out how it's equal. You simplify. You simplify. There we go. Wait, I'm still not done.
3 weeks later, we finally cracked the code.
Law number 4, power to power. I have no sympathy for you because you keep talking. That's why you're not writing. Just keep your mouth shut and write. Simple as that. When a power is taken to another power, you multiply the exponents. When a power is taken to another power, you multiply the exponents. What's the power? That's an exponent. Like 5 to the 5th power is 5, and then a 5 sitting on its right shoulder. When a power is taken to another power, you multiply the exponents. For example, never mind, they can't see that part of the screen yet. Yes, but YouTube can see it. Speaking of YouTube, I got to upload my video from last period. Today is the... Oh, I had that written wrong. 9-7. Fraction decimals, percent notes. I got a notification. This. For example, we have x to the 4th to the power of 3 is equal to 4 multiplied by 3 equal to 12 to the 5th squared. Yes. Yep, because multiplication is in fact repetitive addition, and division is repetitive subtraction.
Wait, so you multiply by 3 wherever x times x times x times x, and then you multiply that by 3, but why wouldn't you just do whatever x is, multiply by whatever x is, multiply by whatever.
And that's how you would get a numerical value, and that's how 2 to the 10th is 10,024. Yes, sir. On your homework tonight, it's nothing but variable simplification. No, because there's no numerical values for variables. I just created it during lunch, so I know there isn't. In the future, there could be one that would simplify, but no homework. No. No, like I told you. There's a reason that you don't have those examples, because you were talking rather than writing after I've told you to be quiet. However, the people around you have those solutions. So we're going to do a couple of examples from the homework, and that'll finish out the class. You're welcome. There we go. Okay.
Whenever Mr. Smith,
Yes.
Mrs. Brown last hour would pass out a paper, he would start smelling it, and he'd be like, "What? It smells like salad."
It did. It smelled like salad.
Whichever one smelled worse, he would give me.
Interesting.
You smell like salad.
Hi. Yes.
My mom was wondering if you were ever going to be able to take home like the tests for like a day.
They can't leave the building. You guys can come in and see it at some point in time, but they can't leave the building. Yep. Sadly. I wish it weren't like that. Accelerated 09/21/2015 homework. Time's running out. Pages. New page. Homework images.
I'm doing a great service to this country. Yeah, saving lives.
Okay, while this loads up, I want to tell you that, please keep loading up. Okay, it's still crawling. Anything to the power of 0 makes that 1. So, for example, for number 2, where it says 3v to the third multiplied by 6v to the 0, that means 3v cubed multiplied by 6 times 1. Okay? Is it done yet? Come on. Okay, did you hear him starting to ask a question that was wrong in the first place, shouting out? Because I'm telling you, anything multiplied by itself can only be the number 1. Okay? Itself 0 times is just 1. And there's you can look it up on YouTube for an explanation and a proof of that, but we don't have time for that right now. Bert?
So it could be like 5 to 0's power.
You know what? 5 to the 0 power? 5 to the 0 power would be just 1. X to the 0 power is just x. Okay, we're going to go right to left. Stephen?
So on number 14, when it says x to the negative fourth power, there's nothing that we can divide by, so that should be a positive 4.
What number?
14. Whenever it says x to the negative fourth power, would that just be actually x to the fourth power?
We'll go over that. We'll do that right now. And why is this taking so long to load? Probably because I'm pressed for time and I only have 2 minutes left. This is very frustrating. Amel? No, I can handle it. Okay, quiet please. Could you repeat that again? People, stop rustling. Stop rustling. And also speak louder. Cubed? Yes. 6 times 1 times m cubed. And come on! Now, I'll do number 14 with you. I'll do number 14 with you. Oh, and I never asked. Stop talking. I don't have to do number 14 with you. Throw you out to the dogs? No? Yeah. Simplifying is solving. But because you can't solve because there's no number values. But for number 14, as I just tried to do, which my computer's being really slow, x to the 4th, y to the 1st, and then that one goes to the 4th. Now, what does the exponent or the power of power say? Yes? Yeah. It says to multiply. So I'm going to have x to the 4th times 4, y to the negative 1st times 4, which is going to be y equals negative 16 multiplied by y equals negative 4. And then what does the law of negative? Come on, I'm not using that program. How do we make these positive?
By subtracting a 1
It makes it be into the denominator. It makes it shoot itself down to the denominator. Make sure I got that one right. So it's x to the 16th, or 1 over x to the 16th, y to the 4th, and yeah, that's your answer. And it's still going? Come on, get out of here. That was hectic.